A special guest tonight. We have Ronen from Practical Meteor to come talk to us. And he's going to talk to us about unit testing and continuous integration with Mocha and spacejam. So give it up for Ronen.
Hi everybody. First of all, before anything else, I need to apologize. The gods of the demos have really messed with me today. My virtual machine, I'm probably the only developer on Meteor that develops on Windows, but with a Ubuntu virtual machine. And the virtual machine crashed today, so I'm going to try and run everything over Windows, and hopefully it's going to be okay. And let's hope that the gods will be forgiving during the presentation. One of my passions is testing and continuous integration. It's something that I always strongly believed in. I've been a CTO of multiple startups through my life. And I've been living since 2010 in the Dominican Republic, enjoying an endless summer, surfing a bit, and also being one of the organizers of the Meteor Dominican Republic meetup. As part of, in most recent years, I tried a couple of ideas in the Dominican Republic, didn't really work, but I did work, I'm working already for 3 years, me and my team with Meteor, and we learned a lot. We've created a lot of open source packages, mainly testing and CI related, and a couple of those are the things we're going to talk about today, which is Mocha and spacejam. So before anything else, first of all, let's talk a little bit about testing types. The types of tests that you usually want to create when you're developing a system are unit tests, which are the lowest level tests, and they test method and function logic in isolation. And usually when we say isolation, it means that you probably want to stub or mock everything that this method or function will call, such databases and APIs and other stuff. And those are the first types of tests, which Mocha is perfect for. The second types of tests are integration tests, where there you have a little bit of more leniency, and you're gonna yes, allow the test to call databases or APIs and other stuff, and you just want to make sure that the system works as expected and things go into the database, APIs are being called with the correct arguments, etc. And then you have end-to-end tests, which are basically trying to simulate use cases from an end user perspective, and there you will probably use browser automation tools such as Seleniums, and you can even use things such as Sauce Labs, which is actually the one sponsoring the Selenium project, and they will even allow you to video record in different browsers and different resolutions all of those end-to-end tests, so the QA department or the product manager can see how the system looks on different browsers and different resolutions. So those are the types of tests, and then there's another two types of tests in a different type of an area, which are called progression tests and regression tests. Progression test is basically the test that you want to write, that are the tests you're going to write or execute, that are going to test things that the new features that you're developing right now, new features and new functionality that you're developing right now. And the regression tests are usually the tests that you're going to run to make sure that the new code that you wrote didn't break old code. And as the system grows a lot bigger and bigger and bigger, the size of the regression test is going to go bigger and bigger and bigger. And if you don't have automated testing, then things are going to start breaking more and more frequently, and you're going to get your co-founder trying and struggle you or something like that. So, why automate testing? I talked about it right now a little bit, but without automated testing, there's a direct relationship between the code base size and the required QA department size that you will need to in order to regression test every time there's a new feature to make sure you didn't break something old. The release cycle length is going to get bigger and bigger, and the chance something broke, of course, 100% is going to get bigger. And what's going to happen with usually development teams, if they don't automate tests, the bigger the system gets, you're going to slowly but surely move development from running to eventually crawling like a baby. So, the other way around. Unit testing with Meteor. Unit testing with Meteor, how can you implement unit testing with Meteor? And we're going to get I'm going to give you a couple of examples. First of all, the best way for me, and this is what we've been doing since the get-go, is we maintain all of our coding packages. The reason we maintain all of our coding packages is because the initial testing framework that came out with Meteor was called TinyTest, and it allowed you only to test coding packages using package on test. So we do maintain all our coding packages. Actually, it's also a good practice because then you can reuse code, and you're going to make sure that you're actually having packages that are modular and are focusing on doing one thing and doing it right. And you're going to use package on test to add your unit test files, which is an API that Meteor has. And then you have two options for actually running for the testing frame. You have more than a few options, but the two options that I like are, one is TinyTest, which is the testing framework that came out with Meteor, and the other one is Mocha, which is a really stable, mature, probably the most mature, stable, and popular unit testing framework for JavaScript in general, which me and my team ported to Meteor, and it works pretty well. There's another port of Mocha to Meteor from the guys' team at Velocity, but it's tied into Velocity, and we try to basically avoid that. We're trying to make it as compact and small and efficient as possible, and I'll talk a little bit later about the differences between our Mocha and their Mocha. And then in order to run those unit tests, you're going to be able to run those unit tests either in the browser or from the command line using another package of ours, which is called spacejam, that allows you to run unit tests from the command line inside Phantom.js. So this is Mocha versus TinyTest, and this is why we think you should basically move to Mocha from TinyTest if you're even using TinyTest. Mocha supports test suite, it supports nested test suite, it supports skipping test or suites during development. So if you're messing with something that doesn't work, you just do .skip and you skip it, and it also allows you to run only a single test or suite. Let's start first of all with a package on test example, which we're gonna show from GitHub. And those are the things that I usually like to use in my tests. First of all, you always need to include the package that you're going to test, which is usually the package under development. In this case, it's easy service config. I'm sorry, not easy service config. Give me a second. Yeah, we can go with that. Okay, there's a package called Easy Meteor Settings. Not yet popular, hopefully it will be, but it allows you to easily read settings for Meteor using a.b.c syntax. Makes your life a little bit easier, not that easier. And in order to test the package, is it big enough? Everybody can read? Zoom in? 1 sec. Better? Yeah. Okay. So, things. First of all, you're going to include the package under test. Then you're going to include different packages you want to use as part of your test, underscore CoffeeScript being an example. You're going to use our Mocha package. And if you want to use TinyTest, you're going to use TinyTest instead. A couple of things I always like to include in my test is, one, proper logging packages, also developed by us, which is probably, I think, the most popular logging package in Atmosphere. If not the most popular, the second most popular. It's a port of a logging package also that we've done with some extensions. Chai, which is a very popular assertion library. Xenon, a very popular stubs and spy library. And of course the code under test. And let me show you how it's going to look. So when porting Mocha to Meteor, we did a quick and dirty decision that we're not going to write our own reporter, and we'll try and just basically make something work as fast as possible. So this is the standard Mocha web reporter. And what we did in order to make it work with Meteor is we just split it into two. So you see client tests on one side and server tests on the other side. It was the fastest to us, but it works, and that's how it looks. One of the things that you can do also in this browser, same as you have in the regular Mocha, you can always, as you can do with tiny test, you can always just decide you want to run something. This is actually Meteor running. Okay. How do you run the tests? Sorry, I missed that.
Where do you put the package?
Hmm?
Where do you put the package file?
The package?
Package file.
I'm sorry, you know what, that's a good question. Before that, is there anybody who never wrote a package in his life? Okay, so quite a few. So when you say the package.js file, the package.js file is basically like, if you're familiar with NPM, it's similar to the package.json file that specifies different things about the package, including the name, the GitHub repository, and the files that should be included in the package. So if you're looking at the package.js file of what we're looking at right now is, this is how you write packages in Meteor.
Where do you put it?
Under the package, in your app folder, under the packages folder. So your structure is going to be something like, one second. Give me a second. Inside the app folder is the Meteor folder. Inside the app folder, you're going to have all of this. How do you run the tests? You're going to run the test by running Meteor test packages. Meteor test packages is the command to run tests within packages. And if you want to run it with our Mocha, you're going to run it with the argument minus driver package. Sorry, it's minus minus. It's not minus. Driver package practical Meteor Mocha. And then you're going to specify the folders of the packages that you want to test. In this case, if I'm inside the package folder, I'm going to specify /, which means test the package inside that folder. But I can specify as many folder or package names as I want. So for example, if you have an app with 5 packages, where you're keeping those packages, your app's code in a modular way, you can basically specify Meteor test packages, all the package names you want to test. Usually what we do during development is that we run our app using on port 3000, the default, and then we run Meteor test packages and test all the packages in parallel at the same time on different Meteor port, on port 3100. And using the Mongo URL environment variable, we also run it on a different database. So the package tests and the Meteor app don't collide MongoDB-wise. Okay? So this is running it from the command line, and I'll give you an example how this is done quickly. In the browser, Windows. Oh, sorry. So this is how the command looks. I hope it's visible enough. Now, by the way, the default driver package for Meteor, The default driver package for Meteor is a testing console. Testing console is a driver package for running unit tests in Meteor that basically runs your tiny tests. I'm sorry, testing browser. Sorry, testing browser. That's the default driver package that Meteor runs in order to run its unit test using the tiny test HTML reporter. Anybody saw? Somebody didn't see the tiny test HTML reporter before? Okay, so won't have time to do it today, but just you can, Meteor itself, the entire Meteor repository has test coverage using tiny test. You can basically clone the Meteor repository, run Meteor test packages in the Meteor root folder, and you will see all the Meteor tests. Which, by the way, is something that Meteor should do. It should add Travis CI integration in order so every pull request can run all of those tests and provide feedback to the pull request creator that he didn't break anything. What? No, I'm thinking of creating a pull request doing that. So back to our issue. This is this is basically the Easy Meteor settings package, running the tests of the Easy Meteor settings package, and then let's see how we can run it from the command line. To run it from the command line, you basically you use an NPM package that we created that is called spacejam. Spacejam is an NPM package we've created in order to be able to run Meteor unit tests from the command line using Phantom.js. So to do that, sorry. There is a wrapper script that instead of having you to force writing the driver package argument, you can run just that, which is called spacejam Mocha, and give it a second. Okay, we already said gods of the demo. You should get the console output out there. Let's continue with the presentation. We'll go back to it afterwards. So, running it from the command line didn't work right now, but basically what you do, you use spacejam, test packages, drivers package, you do Mocha console runner, that's the one that will output the test results to the console. And we created a wrapper script that instead of writing all of this big line, we're basically going to write only that. I'm going to post a blog. I'm going to do a blog post about it in my Practical Meteor blog, practicalmeteor.com blog. So all of this is going to be documented there as well. What's the difference between Practical Meteor Mocha and Velocity's Mocha? So first of all, we don't depend on Velocity. The second thing is, unlike Velocity, where they store all of their MongoDB test results in the MongoDB, we basically we don't use MongoDB to report the test results, which means the tests run much faster. Client test results are reported directly to the reporter. Server-side test results are published to the client using a collectionless publication. The HTML reporter is the basic Mocha one that you saw, split into two. You cannot use our package for our Mocha for now in order to write tests for application code. So your code is going to have to be inside packages. But the big advantage is you can run our tests from the command line using spacejam. Which brings us to the next subject, which is continuous integration. First of all, what is continuous integration? Continuous integration is first of all based on test-driven development, which means more than anything else, test-driven development means that every code that you write, also you have to write test code in parallel to make sure you're going to have regression tests in place. The bigger your system gets, and you're going to know always that nothing broke. And there is a central, in the continuous integration environment, there's a central build and test server that provides to the developer instant feedback on every code push and every pull request created. That's continuous integration. And why do you want to do continuous integration? First of all, the bigger the system gets, you're going to get the tests are going to take more and more time. It can go up to 10 minutes, 20 minutes, 30 minutes, 50 minutes, and the developer shouldn't be the one waiting for all of those tests to finish before he can push his code or create a pull request. So what you usually do is the developer is going to do only the progression tests, but then when he's done developing and the progression tests pass, he's going to push the code to a central build server, which are going to run his tests and then give him at some point in time feedback to make sure that, and let him know if all the regression tests have passed as well. If not, he's going to be able to see the output of the test, build and test, and see what broke, and then fix it again. So the developer is going to be able to work faster. Again, I already talked about that. Make sure the code didn't break anything. Those are the regression tests you're going to run there. And another thing that we also practice is make sure that the mainline, the master branch, the develop branch, whatever you use for the mainline code, is always ready for deployment. So you create a pull request, and if the pull request hasn't passed, including all of the tests, you will never merge into master, and this way master is always kept in great shape. Only pull request that all the tests have passed is being merged into the master. What time is it? How much time do I have more?
How much time do you need?
No, not much. 10 minutes, okay. Using continuous integration, there are many options out there for continuous integration platforms. I made a summary of some of them. Those are the most popular out there. Travis CI, the good thing about it, it's free for open source repos, so it's great for public repos. But if you want it for private repos, it's going to start with $130 per 2 concurrent builds, which is a little bit pricey. But it's also probably the fastest one out there. There's Circle CI, which we use for our private repos because it's free for 1 concurrent build. You have CodeShip, which is also very popular, including with our Nodos team. And they limit the free version to 100 builds a month, and then it's not that pricey. There's a new one called Drone.io, which is based on Go. It's free for open source. It's very cheap for 1 concurrent build. And the good thing about Drone.io is that you can also host it yourself inside a Docker. They set it up beautifully to already be working out of the box. By the way, Travis CI is also open source, but try and set up a Travis CI environment, it's almost impossible. So, and it's based also on Ruby, which you need to be an expert in Ruby in order to make that happen. And then, of course, there's the old school Jenkins, which came out of Hudson, which I've used 10 years ago. And I'll be honest, I don't like it. You usually need to self-host it, and it's very cumbersome and to set up and to configure. I can get people set up with Travis CI or Circle CI in 10 minutes, whereas with Jenkins I'm going to spend a full day in order to be able to configure everything. The good thing about also all the services above here is that all of them have integrations with popular hosting services out of the box, such as Amazon, Google Cloud Platform, Slack, HipChat, whatever. With Jenkins, yes, you do get those as well, but setting them up is hell on earth. So, but your decision. I'm going to give you right now a simple .travis.yml file. By the way, all of usually all of those 4 The way you configure those is with YML files. You can either do it with a UI, or you can do it with a YML file. YML, yet another markup language. Anybody not familiar with YML? Everybody familiar? Okay. So I'm going to give you a simple example how to set up on Travis CI Meteor package tests using a YML file. And I hope this is big enough. So first of all, one of the things that you see is I can even specify inside the YML file, listen, send me notifications about every build that passed or failed into my Slack channel, which is great. That's how we work. All of the builds are being sent into a Travis CI or Circle CI Slack channel, and that's how you know that's how the developer immediately knows if something broke or didn't. All of the way that Travis YML file works is that there is an install section, basically, which installs all the prerequisites for the test, and then there is a script section, which basically is responsible for building and testing the system. By default, you specify in Travis the language, which is Node.js, and if it's Node.js, Travis is smart enough to know that for Node.js, it's usually an NPM package, and in an NPM package, the install step should be NPM install, and the script step should be NPM test. For Meteor, it's not that case, and that's why what we need to do is we need to specify our own commands in order to be able to test Meteor in Travis. And all of those things that you see are basically shell commands. In Travis YML, under install, you can specify as many shell commands as you want, and you can either specify it as multiple commands as you have in the install section, or you can specify it as only one command in the script section. So in the install, we install Meteor, and since we cannot install Meteor into user local bin, you need to add Meteor to the path, and then you install spacejam, and in order to run your package tests, you again use spacejam from the command line, spacejam test packages minus driver package, practical Meteor, Mocha console runner, which is the one that is going to execute the tests and output the results to the console. Let me give you a quick example of how this looks within Travis. One beautiful thing about Travis, you can sign in with GitHub, same with Circle, same with Ronen, all of those. You just sign with GitHub, and you basically can see all the test output. Let me put it bigger. And here is actually a working example of the output of spacejam test packages.
Mike?
Sorry. So I'm repeating for the viewers online is that one of the beautiful things about Travis is you can sign in with GitHub. It's totally integrated into GitHub. And what you can see here is the output of the test results that were run using spacejam and Phantom.js. And you can see that everything is being printed into the console. As I said, I'm going to write a blog post about it as well, so this presentation is going to be in some kind of a form in my blog as well in the next couple of weeks. Going back to the presentation, which is where? Sorry. Something happened here. No, wait. Never mind. There's. Now we're good. Okay, perfect. Thanks. Okay, so what's coming from us next? What's coming from us next is, first of all, with Mocha, we want to support. Oh my God. Okay, don't move. With Mocha, we want to support all the Mocha reporters that are out there. Mocha has many different types of reporters, including reporters that support X-unit output, which some in the community wanted to see. With spacejam, one of the things that we want to do is we want to be able to run the tests from the command line in any browser, not only in Phantom.js. We've seen quite a few times where basically things fail because it's Phantom.js, and Phantom.js is not compatible with Google Chrome or Firefox. So with Selenium, you can run automated tests inside browsers. And that's what we want to try and do. So basically every package author will be able to use Mocha and spacejam in order to make sure that his package works in Google Chrome, in Firefox, in Internet Explorer, and in Safari. That's one of the things we want to do as well. And regarding spacejam.io, this is an idea that we've been having for a very, very long time. We want to create a continuous integration and deployment service tailored specifically for Meteor, which is going to include automated deployments to all popular hosting providers via branches and tags, automated SSL and Cloudflare configuration, which is always a little bit difficult, especially for newbies. One of the things that we've been practicing for a long, long time is dedicated websites per pull request. This is something that follows the 12-factor app principle for whoever is familiar with 12-factor app principle from Heroku. So we have dedicated environments per developer and per pull requests. So how does something like that look? And don't tell Meteor we're doing that because they're gonna, where is it? Yes. So one of the companies we are consulting for right now is called Bontix, and what we're doing basically, as part of the build in Circle CI, we are also adding another GitHub commit status, which basically is a link to the website where the pull request website is deployed. So if I'm going to click on that link, you're going to see that the website is called PR71 Bontix. So what's good about that? Product managers, even end customers, can basically look at the pull request at the new feature and provide instant feedback. Before merging the feature, and that has been very helpful for us, especially working, as I said, against product manager and customer and developers. By the way, it's on Meteor's free hosting. We're, how do you call it, salvaging them. I hope we're going to move away from that at some point in time. Because yeah, we have a lot of pull requests. We have like 3-4 pull requests per day, so we do that. That's one of the things that we wanted to do with spacejam.io, basically create a continuous integration deployment environment that will support that type of feature as well. By the way, with the new Trello, if you guys use Trello for project management, with the new Trello GitHub integration, those commit statuses that show you a link into the pull request website go directly into Trello as well. Finally, we're for hire. We can do quick MVPs, we can do automated testing and continuous integration consultation, get you set up all of that, and we're also very passionate on everything that has to do with business process automation, integration, stuff like that. That's our core and bread and butter. So that's our contact. As part of the blog post, one final thing, as part of the blog post, I will also show how you can use of those assertion libraries and stubs and spies library in order to properly write unit and integration tests. So stay tuned for the blog posts, and that's it. Questions?
Did you mention the load test?
Load tests were not Another thing that, yes, should probably go into such an environment, but no, we haven't done load testing yet. We did port Faker, which is a package for creating fake data, really advanced, into Meteor as well, called Practical Meteor Faker, which can be a basis of some load testing data, but no. But I think that Arunoda is working on something like that.
There is a Meteor down package.
Hmm?
There is a Meteor down package
Okay,
for load testing.
yes. From Arunoda, right? Yeah.
What was the question?
Load testing with Meteor. Load testing with Meteor. Yes.
Isn't Mocha anyhow similar to Gulp or Grant?
Gulp and Grant are a what?
It's a question.
Yeah, if Mocha is similar to Gulp and Grant, no. Mocha is a unit testing framework with test suite. Grant is basically, how do you call it? Let's call it a build automation, exactly. Build automation or some kind of a local continuous integration environment. That's Grant, similar Gulp. So Mocha is more similar to, if you're familiar with Jasmine. So Mocha and Jasmine are the most popular unit testing frameworks. By the way, Jasmine has been ported also to Meteor by, yes. What else?
Someone from the chat here asked if you've been successful working with Cordova on Windows with Meteor.
Because of the blog post about Cordova. Cordova, Windows, yes, Android. Yes, I've been. But, sorry, yes, the answer is yes. By the way, question, who is writing tests as part of their Meteor code? Who isn't writing tests as part of their Meteor code? Who isn't writing tests as part of their Meteor code but has an app in production? And nobody wants to kill you guys? Okay. It depends. Again, if it's an MVP and the thing is validate a business idea, then yeah, you should probably focus less on testing. But if it's starting to be something that creates traction and you want to make sure that your customers are getting a great, excellent experience and deployments you have fast iterations, that's definitely something that I would recommend